Hello students, welcome to Aditya Academy. I am Dr. Ragini Arora and today we are going to start exercise 6.2 from NCERT. I hope you must have watched the introductory video of this chapter which actually explains all the concepts of basic proportionality theorem as well as similarities between two triangles. And we have finished exercise 6.1 in the first video. Now we are going to start exercise 6.2. Now the first question says, in the given figure, DE is parallel to BC. Find EC. Right? So, now what is basic proportionality theorem? Let me explain you in short. We have covered both the important theorems in the introductory video and few examples of this concept. So, I'm giving you a short recap. Basic proportionality theorem states that if a line is drawn parallel to one side of a triangle, let's say this line is parallel to ABC is the triangle and DE is parallel to BC, it is given in the question. In that case, this line, this DE divides the opposite sides in the same ratio. This DE is dividing AB and AC in the same ratio. That means the ratio of parts taken in a particular order. It may be AD upon BD. AD upon BD is equal to AE upon CE. It may be AD upon AB and AE upon AC. So the pattern of ratio which is being taken in one side has to be followed on the second side also. But the basic theorem is this. The actual ratio of two different parts formed by intersection of these 2 points D and E, AD upon BD is equal to AE upon CE. So let us come to this question. In this, it is given that triangle ABC in which DE is given parallel to BC in this question. And we have to find here length of part or segment EC. Right? So here we start our solution. In triangle ABC, DE is parallel to BC. So in a triangle, if one line is drawn parallel to one side of a triangle, it divides the opposite sides in the same ratio. So by BPT, we can write the result by basic proportionality theorem or Thales theorem. We can write AD upon AD, here it is AD upon BD, AE upon CE, right? So AD upon BD is equal to AE upon CE. So what we can do here is, what is AD? Value of AD is given as 1.5 centimeter. BD itself is 3 centimeter. AE is 1 and CE we have to find. So this is very simple. This is 1.5 times CE is equal to 3 times 1, which is 3. So value of CE is 3 divided by 1.5. So CE becomes 2 centimeters. Right? This is basic application of BPT. So now in the next question, it is given that we have triangle ABC in which DE is parallel to BC. And here in this question, we have to find length of AD. So for solution part, again we have to make the statement that in triangle ABC, DE is parallel to BC. It is given that. And then by BPT or by basic proportionality theorem, if one line is drawn parallel to one side of a triangle, it divides the opposite sides in the same ratio. So I am writing that ratio, that is AE upon CE. Now in this question, it is given that AD we have to find over BD. BD is 7.2. AE is 1.8 and CE is 5.4. So by cross multiplying these two, AD multiplied by 5.4 is 7.2 into 1.8. So value of AD comes out to be 7.2 multiplied by 1.8 divided by 5.4. Now you can remove all the decimals, like this becomes 72 by 10, 18 by 10 and 54. 10 you can raise in the numerator. So these two 10 got cut. 18 ones are 18 threes are 54. 3 ones are 3 24s are. So the value of AD comes out to be 24 by 10. So AD is 2.4 centimeter. Right? The next question is, E and F are points on the sides PQ and PR respectively for triangle PQR. Triangle PQR. He's saying E and F are the points on side PQ and PR. PQ and PR. E is point on PQ and F is point on PR. Now for each of the following cases, state whether EF is parallel to QR or not. So now this is, here we have to check whether EF is parallel to QR or not. So here the converse of PPT comes into play. The converse of PPT says that if in a triangle a line is dividing the opposite sides in the same ratio, like if I write this, if AD upon BD is equal to AE upon CE, then we can say that DE is parallel to BC. We had learned this theorem in the introductory video. If you haven't watched that video, please go back. It explains a lot about all these basic concepts. So this is a converse of the theorem of PPT, that if the ratio of these two parts on both the sides are same, then this line DE will be parallel to BC. So here in this question we have to check whether EF is parallel to QR or not. So we have to check for the ratios of these corresponding parts on both the sides, right? In the first part, PE is given as 3.9 and EQ is 3 centimeters. PF is 3.6 centimeter, FR is 2.4 centimeter. So we check for PE upon QE. What is that? PE is 3.9. QE is 3. So if I write it like this, this becomes 39 by 30. Right? So reduce this. This is 10, 3 and 13. Comes out to be 13 by 10. Now check for PF upon FR, which is 3.6 upon 2.4. Remove both the decimals, multiplying numerator denominator by 10, it becomes 36 by 24. So here this is 12 times 2, 12 times 3. We have 3 by 2. So we can see that here these ratios of this part, PE upon QE and PF upon FR, they are not equal. PE upon QE is not equal to PF upon FR. Right? So we can say that in this case, EF is not parallel to QR by converse of BPT. Converse of BPT says that if these ratios are equal, only then this line is parallel to the baseline. But here the ratios are not equal, so EF is not parallel to QR. So we move on to the second part. In this, P, Q, R and E and F are points on PQ and PR. This is the same question with different values. So here PE is 4, QE is 4.5, PF is 8, RF is 9. Right? So we check for the ratios PE upon QE. PE is 4, QE is 4.5. So how can we solve this? I'm writing it as 4.0, multiplying both sides by 10, numerator denominator by 10, it becomes 40 by 45. So 5 8s are 40, 5 9s are 45. Then we have PF by FR. PF is 8, FR is 9. So you can see that we have got these ratios same. So we have now PE upon QE is equal to PF upon FR. The ratios of the corresponding parts like this and this. This comes out to be same. So by converse of BPT, we can say that EF is parallel to QR, right? We have one more part on the same figure. So PQR is the triangle and EF is the line. Now here we have PQ. The whole side is given out to be 1.28. Mark it like this, 1.28. PR is given as 2.56. PE is 0.18 and PF is 0.36. So here we can do this question in two different ways. You must learn that when it says the ratio of this EF is parallel to QR, it divides the opposite sides in the same ratio. That ratio can be written as the ratio between these smaller segments. If we take it this way, PE upon QE, we have to maintain the same format on the right hand side. PE upon QE is equal to PE upon PF upon FR. Or the way it is given in this question, like you can take the ratio between different parts, like PE is the smaller part, and you can take this ratio as PE over this whole PQ. This is also a different way to take the same ratio. And this is if you are taking PF in the numerator, here you have to maintain the same order. If PF is in the numerator, denominator should be PR. PF upon PR. Either you can do it this way, or there is a different way also. Like if it is given that the whole side is taken as 1.28, you can subtract this PE part to get this QE. Or this is 2.56, you can subtract 0.36 to get PFR, then you can take this type of ratio. So I am doing it with this manner, PE upon PQ. This is, I am finding the ratio of PE upon PQ, which is 0.18 divided by 1.28. So multiplying both numerator and denominator by 100, I have 18 over 128. So how can I divide this? 2 times 9, 2 6 2 4, right? This is 9 upon 64. Then we have PF upon PR. PF is 0.36, PR is 2.56. So multiplying both by 100, we have 36 upon 256. Now divide this by 4. 4 9s are 4 6 are 24, 4 4s are 16. It is also 9 by 64. Right? So this is a way I have taken this smaller part by this whole side. On the right hand also this smaller upper part above this whole side. The ratio is coming out to be same. So we can say that PE upon PR is equal to PF upon PR, implies that EF is parallel to QR by converse of BPT. Remember this is only a different way to take ratio. Doesn't mean that we have taken a different result what we have learned in BPT. The only thing is there are 3 different ways to take that ratio. The ways are PE upon QE is equal to PF upon FR. or we can write PE upon PQ is PF upon PR. And finally, we can take this smaller part, the lower one, QE upon whole side PQ and FR upon whole side PR. So all the three different ways of taking ratio are this. So I have used this one to prove this question. Next question says, in this figure, given that LN is parallel to CB and LN is parallel to CD. So we write what is given to us. Given that, and since we cannot, so we have to mark the triangles. In triangle ABC, LM is parallel to BC and in triangle ACD. In triangle ACD, LN is parallel to CD, right? Here we have to prove that AM upon AB is equal to AN upon AD. Keep your target clear. AM upon AB is equal to AN upon AD. See, we have to prove these two ratios equal. Now you have to keep few things in your mind. These, first of all, whatever, if we have to prove two ratios equal by using BPT or its converse, first of all, they should lie in the same triangle. And here we can see that they are in the different triangles. One is in triangle ABC, other one is in the triangle ACD. So what we can do is, these questions are very common to board exams. You will be definitely having such question for 2 marks. What you have to keep in mind is, here AM upon AD can be taken along AL by AC because ACB is a triangle. Similarly, AN upon AD can be taken with AL upon LC because it is in the triangle ACD. Then we can equate the common. So now I'm starting to prove this question. For solution part, in triangle, let me erase this. In triangle ABC, LM is parallel to BC, right? This is given to us. So by BPT, by basic proportionality theorem, I am taking this ratio to be AM upon AB. I have told you, you have to consider the way it is given in the question. Don't always take AM upon MB. If the ratio is taken this way, you have to follow the same pattern for all the things. So now AM upon AB is equal to AL upon LC, right? So AM upon AB is equal to AL upon LC. Sorry, A upon AC. AL upon AC, right? Let this be your first equation. The reason behind this is basic proportionality theorem. Now in triangle ACD, it is given that LN is parallel to CD. Given. So by BPT, it is, you can take this as AL upon AC. AL upon AC is equal to AN upon AD, right? So we have AL upon AC is equal to AN upon AD. This is the second equation. Now see what is common to both the equation. AL upon AC, AL upon AC. AL upon AC is equal to this. AL upon AC is equal to this. That means these two things are equal to each other, right? This is a Euclid's postulate. If one thing is equal to two different things, they are equal to each other. So we have AM upon AB is equal to AN upon AD. This we had to prove, like hence proved. A similar kind of question. In this figure, it is given that DE is parallel to BC. Given DE in triangle ABC, DE is parallel to AC and DF is parallel to AE, and we have to prove that BF upon FE is equal to BE upon EC. Now mark the things in the figure. BF upon FE. Now the next question is, in this figure, in triangle ABC, this is given that DE is parallel to AC and DF is parallel to AE. Here you have to prove that BF upon FE is equal to BE upon EC, right? So now this is a little bit upper level as compared to the previous question. What you have to keep in mind, BF upon FE, look for these parts, BF upon FE, BF upon FE, that means this part, right? And the second one is BE upon CE, BE upon CE. Now here is, you can get confused because both the parts are on the same side of the triangle. So what we have to look for here, one thing is very clear, that if you get confused in the figure, always look for the parallel sides. Always look for the parallel sides. Here DE is parallel to AC. Whenever we have a line parallel to some other side of the triangle, we can apply BPT over there, right? So in triangle ABC, see here, in triangle ABC, look for this whole triangle ABC. DE is parallel to AC. So if this side is parallel to this side, you can apply PPT over here in the manner you are required in the question. BF upon FE. BF upon FE is not falling into this triangle. Look for the other one. BE upon CE. BE upon CE. BE upon CE falls into this triangle ABC. So what we can do is, BE upon CE can be calculated from here. Like if AD is parallel to AC, we can write BE upon CE equal to what? If we are writing BE upon CE from here, it is BD upon AD on the other side. We have to maintain the same pattern of taking ratios, right? So we required BE by CE in the proving part. So we have to calculate it by looking for the suitable triangle. So it is triangle ABC where we have BE parallel to AC, and I am getting this ratio from this triangle. So I have solved it by BPT, right? It is given that DE is parallel to BC and we have applied BPT in this triangle and we have calculated the ratio. This is your first ratio. Now, okay, now I hope this is clear. I am rubbing this part. So now you can see that here we require BF upon FE. And what is the next thing what we are given parallel? This is DF parallel to AE. Now look for this triangle DF. DF is parallel to AE. So what triangle you can take here? It is ABE, right? So in triangle ABE, it is given that DF is parallel to AE. So by BPT, what ratio you can take here? Look for the sides that you require. This is BF upon FE. So it is BF upon FE, right? You are getting this part from this triangle. And what is that equal to? Here, if you go on the opposite side of this, you are getting BD over AD, right? These are two parallel sides. So ratio, the way of ratio we are taking on the LHS, we are following the same method on the right hand side. So BD upon AD. So by BPT, BF upon FE is equal to BD upon AD. This is our second equation. Now we are at the same level. The common thing is BD upon AD that we have in both the equations. So it is BD over AD. You can write here equating equation 1 and equation 2. We have BF upon FE equals to BE upon CE. Right? This is what we had to prove. Hence proved. This is the last question, which is also the same kind of question, right? So here in this triangle, given that in triangle, you can mark the name of the triangles, triangle PQR. In triangle PQR, it is given that DE is parallel to OQ and DF is parallel to OR. What we have to prove is to prove that EF is parallel to QR. Right? This is very easy question. So for solution, first of all, we have to look for the sides which are parallel. DE is parallel to OQ. Now find the triangle. Where is that? DE. This. DE is parallel to OQ. Now can you tell the names like PQO? This is a triangle PQO. In triangle PQO, you can say that ED is parallel to QO. ED is parallel to OQ. So what we can write in terms of basic proportionality theorem? You can write, see here you are not required any ratio. You have to prove two sides parallel. So in the final result, we will be required to use converse of BPT, right? So right now I am taking this ED parallel to QO. So I am writing the ratio which is PE upon QE and PD upon DO. So we have PE over QE is equal to PD upon DO by BPT. By basic proportionality theorem, let this be equation 1. Right? Now we go to the next. Let me erase this so that okay. Now the second thing is DF is parallel to OR. Locate the triangle. DF is parallel to OR. DF is parallel to OR. Now what is the name of the triangle which involves these two sides? So it is in triangle POR. In triangle POR, you can take the ratio as PF upon FR. First write DF is parallel to OR. Therefore, PF upon FR is equal to PD upon DO. PD upon DO by BPT. I hope this is clear. Let this be equation 2. Now see, have you got anything in common in these two equations? This is PD upon DO, this is PD upon DO. So the middle line is common to both the ratios. So what we can do is we can equate these two equations. Equating equation 1 and equation 2. We have PE upon QE equals to, here we have PF upon FR. So let me erase all this so that you can easily get what I want to say, right? See now PE upon QE is equal to PF upon FR. Now you can get a bigger picture in which we have this whole triangle involved, right? Now just forget about these smaller triangles inside this figure. So we have PE upon QE and PF upon FR. the ratio of the two parts or two parts on the left hand side and the right hand side are same. So is there any line joining these two? Yes, this is EF. Now if we consider the whole triangle PQR, you can say that PE upon QE is equal to PF upon FR. So implies that by converse of BPT, these ratios are equal. So we are looking for the line which joins E and F, which is EF. Hence, EF is parallel to the base of the triangle, which is QR. So hence we have proved what we wanted to prove. So this is the way we are going to use BPT and its converse. I hope you liked watching this video. Please do not forget to like, subscribe and share it with your friends. Thank you.